All right, today we are jumping into something really cool. It's a concept from computer science that actually mimics nature to solve problems that seem, well, impossible. We're talking about genetic algorithms, basically code that evolves. So let's start with a really big question. How in the world do you find the perfect answer when you're facing trillions, maybe even quadrillions of possibilities? I mean, think about trying to find the single most efficient route for a whole fleet of delivery trucks, or designing the absolute perfect shape for an airplane wing. The number of options is just staggering.
Now, your first instinct might be, we'll just throw more computers at it, right? Just brute force every single option until you stumble upon the best one. But that's not it. The really elegant and frankly much smarter solution comes from a place you might not expect. It's all about evolution.
And that brings us to this idea of solving problems the way nature does, which leads to a fascinating question, doesn't it? What if our code? What if it could adapt, improve, and evolve, just like a living thing? And that's exactly what a genetic algorithm is. Think of it like this. Your problem is a super tricky lock, and all the possible solutions, they're like a giant box filled with millions of keys. Now, a genetic algorithm doesn't just sit there and try them one by one. No way. It's way smarter. It grabs a whole handful of keys, sees which ones fit the lock even a little bit, and then it starts evolving them. It keeps making better and better keys, generation after generation, until one of them finally clicks and the lock opens.
I know, it sounds almost like magic, right? Evolving keys. But the craziest part is that this incredibly powerful process is driven by a really simple, repeatable three-step cycle.
Okay, so here's how it works. It's this constant loop. First up, selection. You look at all your keys and you keep only the ones that seem to fit the lock the best. Then comes crossover. You take your best keys and you literally mix and match parts of them, creating new, hopefully even better combinations. And finally, you have mutation. You just randomly tweak a few of the keys, change a little notch here or there. This introduces totally new ideas into the mix. And you just repeat. Select, crossover, mutate, over and over. And with every single generation, your pool of solutions gets better and better.
And look, this isn't just some cool academic theory. Out in the real world, this kind of digital evolution has been solving what people once thought were impossible problems for decades now.
So where do these algorithms really shine? Well, they're not for your simple, straightforward problems where you can see the path to the answer. Nope. They are built for what we call black box problems. You know, the really messy, complicated ones loaded with constraints where you have absolutely no idea what the best path forward is. Think about trying to schedule all the flight crews for an entire airline, or optimizing a company's global supply chain. That's where these things are just brilliant.
And the track record? It's honestly incredible. For decades, GAs have been the secret weapon in some huge industries. In logistics, they're creating those near-perfect delivery routes that have to juggle traffic, specific delivery windows, what each truck can carry, all of it. Airlines use them to build these insanely complex but efficient crew schedules that have to follow thousands of rules. And in engineering, this is one of my favorites. They've discovered these optimal and sometimes completely bizarre and novel shapes for parts that no human designer would ever have even dreamed up.
Okay, so that's the history. That's the foundation. But what's really exciting, what's happening right now, is how this old-school evolutionary idea is supercharging modern AI. It's making today's most advanced large language models smarter and a whole lot faster.
Which probably has you wondering, right? So what does all this old-school algorithm stuff have to do with the AI we're all hearing about every single day? Turns out, a lot. Genetic algorithms are the perfect tool for tweaking and optimizing these massive AI models. For example, there's a technique called evo-prompt. Researchers are literally evolving better prompts. They treat words and phrases like genes, mixing and matching them over generations to find the exact combination that gets the best possible answer out of the AI. They're also using them to automatically create more complex training data to teach the models new tricks. And maybe the most practical thing of all, they're optimizing the deep-down underlying code of these models to make them run faster on the hardware we already have.
And what that means for people using this stuff, well, it's a real, tangible, day-to-day win. You get faster AI performance, faster answers, faster training, without having to change the model itself. It's pure optimization, and it's all driven by this idea of digital evolution.
So, if there's one thing to take away from all this, it's that the most innovative solutions for our most complex, modern problems, they might just be inspired by one of nature's oldest and most powerful tricks, evolution. And that leaves us with a pretty wild thought to end on, doesn't it? If we can literally evolve our code to solve our toughest problems, what's the limit? Is there even one?